Video for the quiz on inequality solving, which is lessons 3.1 through 3.4. As we said in class, the only page that seemed to be pretty difficult would be this one, lesson 3.4's practice page, which involves multi-step solving for inequalities. So we'll start out with a few of them. As you notice, I have my scratch paper here so I can show the work for it, and then when I show the work here, I'll write the solutions over here and we'll graph them on the number line that they give us. So for this first problem, it incorporates only 2 steps to solving, but it does have one of the inequality rules, which we'll get to in a moment. So right now, like any problem, I'm going to look to see if there's any simplifying I can do before I start moving stuff from one side to the other. In this case, the negative 3a and the plus 10 are unlike terms, and there's nothing over here at all to simplify. So really we have nothing to simplify. So it means that we have to get into start moving stuff from side to side. In this case, what I really want is this a to be by itself. So ultimately I need to get rid of this negative 3 and the plus 10. And typically the pattern is to get rid of the items that don't have a variable first. So this plus 10 should go away. So since it's plus 10, I'm going to undo it or take it away by subtracting 10 from both sides. And what that will do is cancel the plus 10 out, and that'll leave me with negative 3a on this side. I still have a less than symbol. And then over here, negative 11 minus another 10. It means you're going to go more negative, which takes it down to negative 21. Alright, so now we're left with just the negative 3a. And in this case, what I would say is you want to make sure you get rid of the negative and the 3. And since it's negative 3 times a, I'm going to divide it by negative 3 on both sides. That'll cancel the negatives and the 3's away. And so what I'm left with is a by itself, which is what I wanted. That's a terrible a. And over here, negative 21 divided by negative 3. Well, if I do 21 divided by 3, that's 7. But negative and negative cancel each other out, so really it's just a positive 7 over here. The reason why I left this space here is because this is that inequality rule. If you divide or multiply by a negative number, in this case we're dividing by a negative number, you need to reverse the inequality symbol. So really this goes from a less than to a greater than, and this would be your final answer. So then I'm going to move over here to the paper for a minute. I'll keep that here with me, and I'm going to say that the answer to this one is a is greater than 7. And then the way I graph that is to mark 7, because it's a regular inequality, I'm going to use an open circle, which means that it's not included in my solution, because technically a can't be 7. So the open circle means don't include the 7. And then I'm just going to shade greater than. See, all the numbers that I'm shading over right now are the ones that are greater than 7. Sometimes the easiest way to remember it is that greater than goes to the right and less than to the left. Okay, instead of going to number 2, I'm just going to move down to number 3 here. We'll just keep kind of working in a column. I'm going to go back and do the other ones in a little bit. But so we have a problem here that's going to be a little bit more complex. Again, I look for simplifying ahead of time. Is there any distributing or combining like terms or anything like that? Again, I don't see any of that here, right? What I see is an expression that's divided by negative 5. So the thing I'd really like to do is get rid of this divide by negative 5 part first. So the first thing I'm going to do to cancel dividing is multiply by negative 5 on both sides. And when I do that, both the negative and the 5 cancel each other out on the left. And that's going to leave me with something that I'm pretty used to solving, which is a pretty simple 2k minus 3. Now here again, right away, we multiply by a negative 5. Anytime we anytime we multiply or divide by a negative number, you have to flip the symbol around. So this symbol is going to turn to a less than, and I'm going to have negative 35 over here. Okay, now we're kind of back to where we were in number 1. This minus 3 needs to go away, so I'm going to add 3 to both sides. And when I do that, it's going to be 2k is less than. Now negative 35, I'm going to gain 3 back, so I'm actually going to get out of the negative a little bit. I'm going to go negative 35 plus 3. It's going to take me back up to negative 32. And then the last step of that problem is I need to get rid of that 2 times k, I want to divide everything by 2 so that the 2's will cancel, and I'll finally get k by itself. K will be less than or equal to negative 16. 32 divided by 2 is 16, and since I only have one negative, it'll stay negative. So again, this is a good answer, and we'll go over and graph this on our number line. We're supposed to graph k is less than negative 16. So again, a regular inequality, so I put an open circle on the negative 16, and less than shading, I got to shade all the numbers that are lower than negative 16, which is this way. Okay, let's move up to number 5. Alright, this one I see a little bit of simplifying ahead of time. Here I see distributing, because I have this 6 that I could multiply through these parentheses. To distribute means you take the 6 times every term in the parentheses. So times the n, and also times the negative 8. So if I do that, I'm going to get 6n, 6 times n is 6n, and then 6 times negative 8 is still going to be negative, but it'll be 48 greater than negative 18. So all I did was a little simplifying before I start solving the problem out. So now, just like before, I need to get rid of the part that doesn't have the variable, so I'm going to get rid of this minus 48 by adding 48 to both sides. That's going to cancel the minus 48 away and leave me with 6n greater than or equal to. Now negative 18, so I'm sort of down in the negatives, down in negative 18. I'm going to add 48, so I'm going to come up out of the negatives. So it's going to take me a positive 18 just to get back to 0. But since I have 48, I have to go not only back to 0, but up another 30. So it's going to be plus 30. And then the last step here again, we want the 6 times 6 part to go away, so I divide by 6 on both sides. And I end up with n is greater than or equal to 5. So since this one has an equal to part to it, I'm actually going to use a closed circle or a dot instead of an open one, which indicates that 5 is part of the answer. And then greater than, again, I'm going to shade all the numbers that would be greater than 5, which is this direction. Okay, and then finally we'll move down to one of the harder ones on the page, number 7. So number 7 has a little bit of simplifying to it, maybe even 2 steps worth of simplifying, but really it's actually not that bad. So what I'm going to do is I see this negative 4 squared part, okay? The way I need to read this is, remember, exponents come first. So since this minus sign with it is not in parentheses, it's really 4 squared, which is 16. So this is 7 plus 2c minus, and then the 4 squared is 16. And then see, also I have a positive 7 now and a minus 16 that I can combine together. The 2c is an unlike term, so I'm going to have to leave it alone. But if I take 7 and I subtract 16, now I'm starting with 7, but I'm going to lose 16 off, so I'm going to go into the negatives. In this case, I'm going to be down 9. Like that. And so now I'm in a position where I don't have anything else to simplify, so the only other choice I have is to start moving some things around. In this case, minus 9, to me, to cancel it, I have to add 9 to both sides. So minus 9 and plus 9 will cancel. So that leaves me with a 2c here by itself, less than or equal to. Now here's something kind of weird. Negative 9 plus 9. It's actually like the same thing we did right here. If you start negative 9 down and you add 9 back, you actually just get back to 0. So this is 0. And then if I divide by 2 to get the c by itself and cancel that 2 out, it comes out to be that c is still less than or equal 0 divided by 2 is still 0. So our final solution here is c is less than or equal to 0. So if I go to the number line, I got to put a closed circle on 0 because I'm graphing less than or equal to 0. And where's the stuff less than 0? Everywhere here. Okay, so let's take a look at the other side of the page then. Work on the even numbers this time. Okay, number 2 is kind of back to, much like number 1, a relatively easy one. There is no simplifying involved here, so all we really need to do is start moving some stuff away from the x. So this minus 12 should go first, so we should add 12 to both sides. Adding 12 will cancel the minus 12. And we have 4x greater than or equal to 20 plus 12 is positive 32. And then all I need to do is divide away that 4. It will cancel. X is greater than or equal to 32 divided by 4 is positive 8. That's a pretty straightforward solution, maybe the easiest one on this whole page. So let's go over and graph that one. X is greater than or equal to 8 was our answer. That's a closed circle. And greater than would be all the numbers bigger than 8, like that. Okay, let's go into number 4, which I think might be one of the tougher ones on the page, at least so it looks. But you can actually make it pretty easy if you know how to get rid of those fractions. Okay, dealing with fractions when you solve this kind of problem is kind of tough, because if they're not all the same base, that is, if the denominator is not all the same, it's pretty hard to add and subtract them. And so I would say the easiest thing to do is try to find a common denominator, and if we multiply the whole thing by whatever that common denominator is, it'll actually help us eliminate all the fractions. So when I say common denominator, what I'm saying is I see a 3 and a 5 in the denominators of these fractions. And the only number, the lowest number that they both go into is 15. So if I multiply the whole problem on both sides by 15, what I'm doing is saying 15 times negative 1 over 5. So 15 times negative 1 is negative 15 over 5, and I still got the z there. And then I do it here too. 15 times 2 is 30 over 3, and then 2 times 15 is 30. So you might say, how did that help me get rid of the fractions? They're still there. Well, you can actually divide these numbers now. 15 divided by 5 is 3, and since there's one negative, it's still a negative. It'll be negative 3z plus 30 divided by 3 is 10. So you can see we actually did get rid of all the fractions there. So the key up here was to get rid of the fractions. We find a common denominator that we can multiply the whole problem by, and when we do that, we'll be able to divide those fractions and get rid of them and turn them into nice easy numbers to work with. So once we do that, we're kind of back to a problem much like number 2 or number 1, where we need to get rid of the stuff that doesn't have a z. So let's get rid of the plus 10 by subtracting 10 from both sides. And when we do that, we'll have negative 3z less than or equal to 20. And now your last step will be to divide by negative 3 on both sides. The reason why we divide by negative 3 is to cancel the negative and the 3. That'll leave us with z by itself. Remember, now we divided by a negative, which means we have to reverse that symbol. So now it's going to be a greater than or equal to. And 20 divided by 3, okay, that can be kind of a pain. But the question is if you want, you could either leave it like a fraction like that, or turn it into a mixed number or a decimal. But we know it's going to be negative because there's only one negative. And then 20 divided by 3, well, 3 goes into 20 6 times with 2 left over. So it's negative 6 2/3. So our final answer is Z is greater than or equal to negative 6 2/3. And if you look at your number line on your page, you can actually see that they specifically marked it in there, so they're telling you that that must be the right answer. So it's supposed to be greater than or equal to, so we'll put a solid dot somewhere where negative 6 2/3 would be, like that, and greater than shading would go to the right, covering all the numbers that are greater than negative 6 2/3. So really, guys, they were trying to make it harder by putting some fractions in there, but the problem ultimately is done the same way as almost all the other ones, with the exception of multiplying to get rid of those fractions. So they tried to kind of make it scary when it really isn't that bad. Alright, number 6 has some distributing in it, but there's an extra step of potential mistake in here, and it's right here with this minus in front of the 2. The minus 2 here, when you distribute, this needs to be treated like a negative 2. And so this negative 2 gets multiplied times both of those things, not just the 2. So when you write this, the 10 right here is still positive. But now we have negative 2 times 3x. That's going to be negative 6x. And we have negative 2 times positive 4, which is negative 8. All still less than 11. See, we're not done simplifying yet, though, because now we have some like terms to take care of. So I have a positive 10 and a negative 8 that are like terms. The 6x is not a like term. So positive 10 minus 8, well, I think we all know 10 minus 8 is 2. So what we really have here is negative 6x, and 10 and negative 8 actually work out to positive 2. Less than, oops, I added that in there, sorry, less than 11. So again, we're back to the normal kind of problem we've been working on. The plus 2 should go away by minus 2 on both sides. And I now have negative 6x less than 9. And to get the x by itself now, I would divide by negative 6 to cancel the negatives and the 6. So I'm going to get an x by itself. I divided by a negative, so I have to reverse the symbol. Now it's greater than instead of less than. 9 divided by 6. 6 goes into 9 one time with 3 over 6, or 1/2, left over. And there's one negative sign, so it's a negative. So our final answer is x is greater than negative 1/2. So again, if we go over to our graph, or excuse me, our paper, the number line had a negative 1/2 marked on it, so again it gives it away that that's the right answer. But we have just a plain inequality, so I'm going to put an open circle where that would be. And then greater than shading is again to the right. Okay, last one of the standard problems that we have. Number 8. I see some distributing here, so I'm going to take care of that. 15p 3 times it goes to p and to the negative 1. So I see 3p minus 3 greater than. Now on this side, you should know that parentheses come before anything else, but even if the parentheses weren't there, the exponent is the next thing in line, so you're going to do 2 to the third first before you multiply it by this 3 out here. So 2 to the third, that's 2 times 2 times 2. So 2 times 2 is 4, times 2 again is 8. So this is 8. The reason why I left that there like that is because in this side over here, we actually have some like terms with the variable terms this time. The 15p and the 3p, they can be added together to make 18p minus 3 greater than 3 times 8 is 24. So this problem looked really ugly, but really after a couple steps of simplifying, it's down to a pretty standard problem. So we'll add the 3 to cancel it. And I get 18p is greater than 27. And now if I divide by 18 to cancel out that times 18 part, finally I get p is greater than 18 goes into 27, where you can reduce this. This is, if you think about it, 9 goes into 27 3 times and into 18 twice, so it's really 3 over 2. But if we want, we can change that to a mixed number. 2 goes into 3 one time with 1 left over. We get p is greater than 1/2 again. Sometimes with these more complex problems, you get answers that don't always work out to perfect whole numbers. So it doesn't hurt to know a little bit about fractions here. But again, if we go over to our paper, p is greater than 1 1/2 is our answer. And there again it is marked on the paper. We want an open circle where that would be, because it's a regular inequality, and greater than shading goes to the right once again. Okay, so I worked out all of the plain like algebra problems for you, and then the ones I really like, and of course that are very prominent on the Keystone, are these word problem types. So if you've seen the pattern that we're talking about throughout these problems, you know, much like number 2, for example, up here, where you have something multiplied by the variable, and then there'd be an adding or subtracting, and then the inequality, and probably a regular number on the other side. That's kind of how you'll set up these inequalities down here, so we might as well kind of keep that pattern in mind when we go to write it. So it's talking about a full year membership to a gym that costs $325 up front and has no monthly charge. So that's one alternative. You could go for a year for $325. Or the other alternative is you have a monthly membership that costs $100 up front and then is $30 per month. So it says, for what numbers of months is it less expensive to have a monthly membership? Okay, so what it's saying is, in the original directions, write and solve an inequality for each one. Okay, so what I know is that the monthly membership, what I want to know is, when is it less expensive to have the monthly membership? Well, okay, less expensive than the year membership. So the year membership is $325. So what I really want to know is, when is that monthly thing going to be less than $325? Now the only thing is, I need to write an expression for the month. Well, how did I get it? I had to pay $100 up front and then $30 per month. So the $100 gets paid once, but the $30 gets paid every month. So there's my inequality. Now if I solve it, I'm just going to rewrite it right here. If I solve it, I'd want to take away the thing that doesn't have a variable, so I'll take the 100 away by subtracting. And now I have 30m is less than 225. And then I take the 30 away by dividing. And what I get as an answer is m is less than 7.5. So what I should know is, what does that answer really mean? So to me, when I get an answer that says m is less than 7.5 and I know m is the months, what I would say is that it's cheaper monthly for anything up to 7.5 months. That's what my answer means. So as long as the number of months is less than 7.5, it'll be cheaper to pay by month than it is to pay yearly. But you can see, I mean, basically, at this monthly rate, you'd have the last 4 months of the year for free, if you paid for the yearly rate. So this membership place is trying to sell you on the idea that if you stay for a whole year, we'll charge you $325, but if you only want to go month to month, it's going to be $100 plus $30 a month. Sooner or later, actually, after 7.5 months, it's better to have purchased the year. Okay, last one. Again, keeping the idea of the inequalities in mind, how we're supposed to write it. It says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. What are the possible values of x for this triangle? The sum of the lengths of any two sides, so I can pick any two sides, and they must be greater than the length of the third side. So how about this? What if I choose the two sides that are variables, 3x and x plus 5? Sum means to add them, so I'm going to say 3x plus x plus 5. And I know they have to be greater, this thing has to be greater than the third side, which is 40. So you could have written this a little bit differently. As long as you took two of the sides over here, added them, and made it greater than the third side, it would be okay. I think this is pretty much the easiest way to write it. So I have a little bit of combining like terms to do. 3x and x are like terms. So this is 4x plus 5 greater than 40. Now I'm going to subtract the 5 away. 4x greater than 35. And then finally I'm going to divide by 4. The 4's cancel. X is greater than, well, 35 by 4 divided by 4 is not quite 9, it's a decimal. It's going to be 8.75. So what I'm saying is that as long as x is greater than 8.75, this picture can be true. Alright guys, that's the end of 3.4 worksheet page. I would say you definitely should take a look at these word problems, especially number 9, because that's the kind of stuff you're going to see on the test for a word problem. And obviously this is the page that I felt like we needed to go over, so there'll be some things pulled off of this page.